Good morning, ma'am. My name is Nikita. I am from EC branch. My subject is Internet of Things, and my topic is improving network management with software defined networking. Coming to introduction, in today's world, managing computer network can be a real headache. Think about all the devices we use every day, like phones, laptops, smart TVs, etc. All including to connect to the network smoothly and securely. Traditional way of managing network have their limits. That's where software defined network where SDN comes in. SDN is like a new way of running the show behind the scenes. It separates the brain of the network, the control part, from the actual device that sends and receives data, which is the data part. By doing this, SDN let us manage devices networks in a more flexible and efficient way. In this introduction, we will break down what SDN is all about. We will start with why we need it and how it's different from the old ways. Then we will explain the basic part of SDN like the control center and the devices. We will also talk about why SDN is exciting. It makes things like setting up networks and sharing resources easier and faster. But it but it's not all smooth sailing. SDN comes within its own challenges like making sure it's secure and compatible with different devices. Kush appude పోయింది. Abstract. Software defined networks has emerging as a transformative approach to network management, offering enhanced flexibility, scalability, and programmability compared to traditional networking paradigms. This examines the potential benefits and challenges of employing SDN to improve network management. We will discuss the fundamental principles of SDN, including centralized control, secured separation of data and control planes, and programmability through open interface like OpenFlow. Further, we explore various use cases where SDN can revolutionize network management, such as dynamic resource allocation, network visualization, and policy based traffic engineering. Additionally, we highlight key challenges in deploying SDN, such as security concern, interoperability issue, and scalability limitations. By addressing these challenges and harnessing the capabilities of SDN, organization can realize significant improvements in network management efficiency, agility, and cost effective, and which include some principles of SDNs and centralized controls and some data control planes and the interface the interface like a open flow. How does software defined network works? Software defined network working is becoming increasingly popular in big data centers like vans, branch offices, campuses, data centers, networks, and telecom networks for an exciting reasons. It increases network efficiency with its ability to dynamically allocate resources to reduce maintenance cost and operational complexity. SDN is emerging as a powerful tool for modern network. In software defined networking, the software is developed for the hardware. The control plane, which determines where traffic should be sent, is moved to software by SDN. But the data plane, which sends information, remains in hardware. This allows networks administrators who utilize SDN to program and hardware the whole network from a single control point rather than by the devices, which has ability to allocate dynamically to reduce maintenance cost. SDN eliminates the needs for individually managing devices such as traditional routers or switches. This has implications for the architecture, economics, and security of an enterprise networks. While there is no one model for software defined networking, the topology of these kind of network has changed over time. The open flow paradigm, which was crucial in SDN's early development and standardizations, was one of the earliest SDN communication protocol. The strategy managed by the Open Networking Foundation requires businesses to deploy physical network elements such as SDN controller, routers, and switches explicitly designed to support the OpenFlow protocol. As SDN grew, mainly people discovered that the basic paradigm was too restrictive and devised alternative methods. SDN architecture. It consists of an application layer, control layer, infrastructure layer. First, what is application layer? The application layer contains the standard network applications or functions business utilize to enhance application speed, simplify IT, and boost security. Examples of these systems are instructions decision system, WAN optimization controllers, that is WOC, and load balancing systems and application firewalls, and which consists of a standard some applications which is used for application layer. Traditional network requires dedicated network equipment for these duties. A software defined network substitutes the device with an application that manage data plane behavior through a controller. Programs on the application layer transmit particular network instructions to the SDN controller. Control layer. The control layer is a change of charge of network policies and traffic flow. The requirements presented by the application layers are processed by the control layer, which subsequently sends them to the underlying network infrastructures. The control layer also sends data from the infrastructure layer back to the application layer to improve functionality. The SDN controllers, which links the applications and infrastructure layers, is post of the control layer. SDN controller software offers a centralized view and control over the whole network. Network terms use the controller to regulate how the underlying infrastructure forwarding layer handles traffic. Infrastructure layer. In the data center, the infrastructure layer houses the network's actual switch and routers. It layers the actual switches. These network devices are in a charge of crucial forwarding function and data processing capabilities and gather critical information such as networks use and topology to report back to the control layer. They both three layers communicate using northbound and southbound APIs. The northbound API allows communication between the control and application layer, while the southbound APIs will enable communication between the control and infrastructure layer. Here is an architecture of SDN, which has application layer, control layer, and infrastructure layer. Application layer consists of a load balancer and firewalls, with the control layer consists of SDN controllers, and the infrastructure consists of three different types of switch devices. And northbound APIs is connected between application layer and control layer, and southbound APIs is connected between control layer and infrastructure layer. Northbound APIs. Applications in the software defined network rely on the controller to inform them of the network infrastructure's availability to determine what resources are available. The SDN controllers can automatically granuate that application traffic is routed according to the set policies. The control layer orchestrates how available resources are allocated to the apps in the network, which includes some Latency and security. Northbound APIs are typically RESTful APIs. Southbound APIs. The SDN controller uses southbound APIs to connect with network infrastructure such as routers and switches. The network infrastructure is informed of the path the application data must take as determined by the controller. The controller can modify how the routers and switches move data in a real time. The data no longer depends on devices and routing tablets to determine whether it travels. Software defined network versus network function visualization. The software defined network separates control plane and data plane by centralizing control and programmability of the network. Where the network function visualization helps visualize functions by transferring network functions to virtual servers. Conclusion. SDN is a compelling development for the public sector. It helps to simplify operations by automating and centralizing network management tasks. It makes the network more responsive to dynamic business and institutional needs by coupling applications with the network control. Finally, SDN gives IT teams more eligibility because they can quickly customize network behavior for emergent business needs. The increasing velocity of application development will continue to drive IT organizations to deploy technologies that allow them to scale and respond to rapidly challenging demand. Thank you.